Good evening everyone, good evening. I welcome all of you again to your JEE Enthuse. I hope all of you are doing great, having a good time. So people, if I'm perfectly audible and visible to everyone, quickly let me know in the chats. Hello Manisha, hi Aisha, hello Nandini. Good evening everyone, good evening. Quickly let me know in the chats if I'm perfectly audible and visible to everyone. Hello Hema, welcome to Vedantu JEE English channel. Welcome back all my lovely students. Just give me some green signal from the chats, my dear people, if I'm perfectly audible and visible to everyone. Yes. Hello Debarati, welcome to the channel. I'm doing good Nandini, thank you, I'm doing good, thank you. Perfect guys, so as you all must be knowing, tonight we are going to have the session on the most expected questions from the chapter P block elements, right? Well, in this particular session, I have come up with around 50 questions from the chapter P block elements. I would want you guys to remember all these questions one by one, right? Hello Ravi, hi Rupesh, hello Virish. Welcome back people, welcome back. So people, before starting tonight's discussion, the ones who have just joined in, the ones who are new to the channel, let me quickly introduce myself. Well, my name is Wassim and I'm your chemistry master teacher right here on this JEE Enthuse channel, right? Well, the ones who not like the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this JEE Enthuse channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well. Yes, people? Perfect. Let me know quickly, my dear people, in the chats if you all are super duper excited about this particular session as well. Yes? Let me know in the chats, my dear people, if all of you are super duper excited about this particular session as well. Let me know quickly in the chats. I'm looking at your chats only. Yeah? Perfect, guys. Perfect. Alright, so let's get going then. Let's get started with the first question from the chapter P block elements, which is going to be on your screen in 3, 2, 1, and now. This is the first question on your screen, my dear people, and let me know quickly the answer of this particular question in the chats, right? I am looking at your chats, right? I am looking at your chats, my dear people. Let me know quickly, what do you think about this particular question? A xenon compound A upon partial hydrolysis gives XeO2F2. The number of lone pairs of electrons present in the compound A will be. What do you think about this? Well, Shahid is coming up with the answer as 10. What about the rest of the people? What about rest of the people, my dear? Alright, well, I can see majority of the students are coming up with option A. Let's exactly get to know what is going to be the correct answer of this particular question. First of all, let me tell you, it is basically XeF6 which upon partial hydrolysis gives XeO2F2, right? So the compound is basically XeF6 which upon partial hydrolysis is going to give us XeO2F2. Now as per the question, what am I supposed to do? I'm supposed to calculate the total number of lone pairs which are there in, the total number of lone pairs of electrons present in the compound A will be. I need to calculate the total number of lone pairs of electrons in this XeF6, right? Let's exactly have a look how many lone pairs are there in XeF6, right people? Have a look. First of all, if you talk about xenon, my dear people, if you talk about xenon, how many valence electrons it has? It has got some 8 valence electrons, right? It has got some 8 valence electrons, absolutely. Now people, let me tell you how many sigma bonds this xenon is forming. Since it's forming 6 sigma bonds with fluorine, right? So out of 8 valence electrons, xenon is using 6 of its valence electrons to form 6 sigma bonds. So there'll be 2 electrons left as such on xenon in the form of its lone pair. So there is basically 1 lone pair on xenon. There will be 1 lone pair on xenon, right? So 6 sigma, 1 lone pair, number 1. Number 2, see, you got to know exactly there is 1 lone pair on xenon, right? So there is basically 1 lone pair on xenon, right? And towards this xenon, there are some 6 fluorines attached. On every fluorine, there will be 3 lone pairs, right? On every fluorine, there will be 3 lone pairs. As simple as that, right? Because if you talk about fluorine, it has got some 7 valence electrons, right? one of its valence electron it's using to form one sigma bond. So there'll be 6 electrons left as such on fluorine in the form of 3 lone pairs. So basically on one fluorine atom there are 3 lone pairs. So on 6 fluorine atoms there will be 18 lone pairs, and apart from that there is 1 lone pair on xenon. So total there will be 19 lone pair of electrons, right? So the correct answer of this question is going to be option D, right people? A very simple and basic question this was, provided you know this XeF6 upon partial hydrolysis, it gives basically your XeO2F2, right? And if you talk about XeF6 in particular, xenon has got 1 lone pair, 1 fluorine has got 3 lone pairs, so 6 fluorines will get 18 and 1 that comes out to be 19. So 19 lone pair of electrons will be there in total in this XeF6 which I was supposed to calculate as per the question, right? Simple and basic. Moving on to one more. Which among the following is the most reactive? What do you think about this particular question, my dear people? Which of the following among all is the most reactive? Is it going to be chlorine, bromine, iodine, ICl? Which one among the following is going to be most reactive? Well, I'm getting the correct answers. Majority of the students are giving the correct answer. That's absolutely wonderful. It's basically going to be ICl, right? It is the interhalogen compound. It is the interhalogen compound. And this is going to be generally most reactive among all the halogens except F2, but I have not mentioned F2 over here, so leave F2 aside. Among all the given options, ICl is going to be more reactive as it is the interhalogen, right? There will be basically electronegativity difference between iodine and chlorine, due to which there will be some ionic character over here, right, which makes it more reactive as compared to the other halogens except F2, right? So ICl is absolutely going to be more reactive among all these halogens, right? Simple and basic. Moving on to one more, my dear people. What do you think about this particular question? You would have come across all these statements in your NCERT textbook as well. I'm sure about that. What do you think about this? What do you think about this particular question? The correct statements regarding group 13 element oxides, right? The correct statements regarding group 13 element oxides. Well, the statements are given. Boron trioxide. Boron trioxide is acidic, which is absolutely right. Oxides of aluminium and gallium are amphoteric, absolutely right. Oxides of indium and thallium are basic, absolutely right. All the 3 statements are absolutely correct, my dear people, right? So basically, when we talk about the oxides of group 13, on moving from top to bottom, basic strength of these oxides actually increases, right? Basic strength of the oxides actually increases, which makes all these 3 statements absolutely correct, right? So option A is the one which is going to be the correct answer of this particular question as well. I'm sure you got to know, right? If you talk about these trioxides of these group 13 elements, right, on moving from top to bottom, their basic strength actually increases, right? The first one is going to be acidic, then amphoteric, basic, right? So all the statements are absolutely correct which were given to us. Let me quickly move on to one more. Chlorine gas on reaction with hot and concentrated sodium hydroxide gives. What do you think about this one? I'm sure this reaction you would have studied in your redox reactions as well, right? I would want your answers in the chats, my dear people. Chlorine on reaction with Cl2 on reaction with hot and concentrated NaOH, right? Hot and concentrated NaOH. What does it produce? What does it give? First thing, it is absolutely going to give NaCl, right? Apart from NaCl, it's going to produce NaClO3, right? And with this, you'll be getting water as well. So basically, it is the common example of the disproportionation reaction wherein Cl2 undergoes disproportionation. As simple as that. Now, people, see, over here, in case of NaCl, just a second.
All right then, I won't.
There is something wrong with my phone, my dear people. Just a second. Siri started to work on its own. I don't know why. Okay. All right. So in case of NaCl, it is basically Cl negative, and this is basically going to be basically ClO3 negative, right? This is going to be ClO3 negative. This is basically ClO3 negative, and over here you are getting Cl negative. So what is going to be the correct answer of this particular question? It's going to be Cl negative and ClO3 negative is going to be the correct one, right? Simple and basic again. So basically over here, if you look at this particular one, over here the oxidation state of chlorine is 0, Right here the oxidation state of chlorine is -1, and over here the oxidation state of chlorine is +5. Check it out. 0 to -1, decrease in the oxidation state means reduction. 0 to +5, increase in the oxidation state means oxidation. So Cl2 is simultaneously undergoing oxidation and reduction. So I must say in this particular reaction, Cl2 is undergoing disproportionation. As simple as that, right? Perfect. So let me quickly move on to one more question, my dear people. All right. The shape of XeO2F2 molecule. What is going to be the shape of XeO2F2? See guys how to make its shape. This one is simple, right? If you talk about XeO2 and F2, right? First thing, how many valence electrons this xenon has? Xenon has got some 8 valence electrons, as you all must be familiar with, right? How many terminal atoms are attached with xenon? 2 and 2. There are 4 terminal atoms attached with xenon. Do remember, the number of terminal atoms always gives you the number of sigma bonds. So there are basically 4 sigma bonds, right? Now, if I make its rough structure, my dear people, if I make its rough structure, xenon is attached with 2 oxygen atoms, oxygen being bivalent like this, right? And this is fluorine, this is one more fluorine. Have a look. Out of 8 valence electrons, how many valence electrons the xenon is using for the formation of bonds? 1, 2, 3, 4, 5, and 6. Out of 8 valence electrons, 6 of the valence electrons have been used. So there'll be 2 electrons left as such on xenon in the form of its lone pair. So 4 sigma, 1 lone pair. That's it. What is going to be the type of the molecule? Isn't it going to be AB4L1, my dear people? Right? If I ask you what is the hybridization, sigma plus lone pair, steric number comes out to be 5. If the steric number is 5, the hybridization is sp3d. Right? Which d orbital is involved in the hybridization? It's dz square. Right? What is going to be the shape of this particular molecule? 4 sigma, 1 lone pair. It's absolutely going to be seesaw shaped. Right? So there is one option as the option D, which says it's going to be seesaw shaped. Absolutely, it's the correct answer of this particular question, right? I'm sure it's clear. Right, people? Moving on to one more. In borax bead test, which compound is formed? This is a very, this has been many a times asked in your competitive examination like JEE, right? Regarding borax bead. So, in borax bead test, which compound is formed? Which compound is formed? Absolutely, Darshini, you're absolutely right. It's going to be metaborate. Absolutely, it's basically going to be the metaborate which gets formed in the borax bead test. Okay, this is one paragraph which has been directly taken from the NCERT. Have a look on this one. On heating, borax first loses water molecules and swells up. On further heating, it turns into a transparent liquid which solidifies into a glass-like material known as borax bead. Right? This is, from this borax bead, frequently questions have been asked. So have a quick eye on this particular borax bead test as well, right? All right, match list 1 with list 2. You're supposed to match list 1 with list 2. See, these are very common processes, my dear people. Haber's process. It's used for NH3 synthesis, right? If you talk about Ostwald's process, it's used for HNO3 synthesis. Contact process, it's used for H2SO4 synthesis. Hall-Herold's process, it's used for aluminum extraction, right? So look at all the options, my dear people. Haber's process with 3, A with 3. So option C is the one which is basically going to be the correct answer of this particular question as well. I'm sure you guys are remembering all these things with me, right? So option C is the one which is going to be the correct one among all. Yeah? All right, one more question, my dear people. Which of the following are not correctly matched? Which of the following are not correctly matched? What do you think? See guys, germanium dioxide, it's absolutely acidic, right? PbO2 is amphoteric. Carbon monoxide is neutral. Look at this one, silicon dioxide. Is silicon dioxide amphoteric? No. Silicon dioxide is acidic basically. Right? It is acidic. So it is basically going to be option 4. Where is 4? That means B, right? This is going to be the correct answer of this particular question. Right, people? So all of you must be knowing about carbon dioxide, about GeO2, germanium dioxide, and SiO2. These are basically acidic oxides, right? These are basically acidic oxides. So do remember them. So it's option B, which is incorrectly matched, right? That's something which I was supposed to identify. Perfect. All right, the bonds present in N2O5R. This is something which I'm sure every one of you are going, every one of you are going to let me know the correct answer of this particular question. The bonds present in N2O5. What all bonds are there in N2O5? These are absolutely going to be covalent and there will be coordinate bonds as well, right? Absolutely, people. Absolutely, it's going to be covalent and coordinate. Absolutely right. Perfect. I hope you know the structures. These are the structures of it, right? This is the structure of your N2O5, either this one or you can write that one, right? Which includes your covalent and coordinate bonds, right? And the structures of the oxides of nitrogen, these are again given in your NCERT, so have a proper eye on the structures of the oxides of the nitrogen, right? Anything can be asked out of these, right? How many coordinate bonds are in this one? How many coordinate bonds are in that one, right? How many lone pairs will be there? What is the formal charge present on atoms? Anything can be asked out of the structures, right? So do remember these structures in detail. Okay, one more question, guys. It is because of inability of NS2 electrons of the valence shell to participate in the bonding, right? Inert pair effect, my dear people. Due to which, what happens? Sn di positive is oxidizing while Pb plus 4 is reducing. Is this correct? No way, right? It's not going to be correct. See, due to the inert pair effect, people, due to the inability of the Ns2 electrons of the valence shell to participate in the bonding, let me tell you, Sn di positive is not oxidizing, it's reducing in nature. It's reducing. And Pb plus 4 is oxidizing. So this should have been the correct one. This should have been the option given, right? So this is going to be the correct answer of this particular equation. Sn di positive is reducing, Sn di positive is reducing, while Pb plus 4 is oxidizing. Just a second, not this one, sorry. Sn di positive is reducing, while Pb plus 4 is oxidizing. So it's option D, which is the correct answer of this particular equation, right? This happens basically due to the inert pair effect only, right? The reluctance of Ns electrons to participate in the bonding, right? Okay. The correct decreasing order of basic strength. This is a very common question and I'm sure you all must be knowing about this one. You can let me know its answer fast. You can let me know its answer fast in the chats. Well, you are given with the hydrides of group 15, my dear people, right? You are given with the hydrides of group 15, talking about NH3, right? Then PH3 is given, right? ASH3 is given, right? SBH3 is given. These are the hydrides of group 15. Perfect. You need to arrange them on the basis of their basic strength, right? See guys, nitrogen has got the lone pair over here. Similarly, phosphorus has got the lone pair. Every central atom over here has got the lone pair, right? Now basically, nitrogen, since its size is the smallest among all these central atoms, right? So it has got maximum electron density among all these central atoms, by means of which it can coordinate its lone pair easiest as compared to the rest, right? It has got the maximum tendency to donate its lone pair, you can say. So any species which has got the tendency to donate its lone pair, that acts as the Lewis base. So NH3 has got the maximum basic character among all of these, right? So as you move from top to bottom, what is happening with the basic strength? It is decreasing, right? NH3 will be maximum, followed by PH3, followed by SH3, followed by SBH3. So it's option C, which is again going to be the correct answer of this particular question, right, my dear people? I'm sure this one is also clear to you. I'm quickly moving on to one more. Which of the following has peroxide linkage? Where do you see the peroxide linkage among all, my dear people, right? Where do you see the peroxide linkage? I would want your answers in the chats. What do you think? Is it going to be H2S2O6, H2S2O8, H2S2O3 and H2S4O6? Absolutely, it's H2S2O8, which you call as Marshall's acid as well, right? If you want to have a look on the structure of H2S2O8, it is something like this. This is basically the structure of your H2S2O8, which we call as Marshall's acid, and over here in between you can see this is the peroxide linkage, right? So that's something which you wanted to check. Yeah? So it's H2S2O8, which is going to be the correct answer of this particular equation. Well, it's better to remember the rest of the structures as well. It is better to remember the rest of the structures as well, because anything can be asked from the structures, my dear. Question can be wherein there is no SS bond present, wherein there will be SS bonds present, like that, right? What is the oxidation state of sulfur in any of these, right? Anything can be asked out of these. So do remember all these structures. These structures are given in NCERT as well. Well, this is a very common question. PCl5 is possible, whereas NCl5 does not exist. Why? What is the reason behind that? What is the reason behind that? Because in case of nitrogen, we do not have the d orbitals present, right? Whereas in case of phosphorus, due to the presence of the vacant d orbitals, it forms, right, PCl5 as well. Nitrogen, it cannot exceed its covalency beyond 4, right? Nitrogen cannot exceed its covalency beyond 4. So it's going to be option A, which perfectly fits this one, and I'm sure you all already must be knowing about this. Okay, among the following oxo acids, the correct decreasing order of the acidic strengths, right? How do you arrange them on the basis of their acidic strengths, right? These are the acids of chlorine which are given to me. So first thing which I'll be doing, I'll be calculating the oxidation states of chlorine, right? I'll be calculating the oxidation states of chlorine, yeah? Wherever you see the maximum oxidation state of chlorine, that's going to be maximum acidic. So people, if you look at this one, the oxidation state of chlorine is +7, right here it's going to be +5, right? And over here it's going to be +3, right? And over here it's going to be +1. Perfect. So whatever is going to be the decreasing order of the oxidation states of the chlorines, same is going to be the decreasing order of their acidic strengths. So absolutely, it's option B. It's a very common question asked many a times in different competitive examinations, right? So do remember this. You just answer this particular question with the help of the oxidation state of the chlorine. More the oxidation state of chlorine, more is going to be the acidic strength. That's it. All right. One more memory-based question, provided you remember the reactions. Zinc on reaction with dilute HNO3 gives X, and zinc on reaction with concentrate HNO3 gives Y. Identify X and Y, right? Let me tell you, when zinc reacts with dilute HNO3, it leads to the formation of N2O. This is one of the byproducts which gets formed in the reaction. And when the same zinc, when it reacts with a concentrated HNO3, there will be formation of NO2 as well, right? So basically, this X is going to be your N2O and Y is simply going to be your NO2, right? Look at all the options, N2O and NO2. So it's option D, which is the correct answer of this particular question. If you want to have a look on the reactions as well, you can check it out. Say N2O in the dilute one and NO2 in the concentrated one. That's it, right? Do remember these two reactions as well. I'm sure you are taking the screenshots with me, or else you can get the PDF of this session in the Telegram group afterwards. All right, there is no SS bond present in. There is no SS bond present in. Where do you not see the SS bond? It is absolutely going to be what, people? Let me know fast in the chats. I'm looking at your chats only. What do you think about this one? There is no SS bond present. Wherein there isn't the SS bond present. Is it going to be S2O7 dinegative? Right? S2O7 dinegative? Right? I'm sure. Darshini, it's not Marshall's. It's oleum. It was oleum basically. H2S2O7. From oleum you got S2O7 dinegative, right? H2S2O7 is something which we call as oleum. It's not Marshall's. Marshall's is H2S2O8, right? Anyways, you are perfectly correct. It's option D only, wherein there isn't SS direct linkage. Yeah? Right, people? If you want to have a look on its structure as well, you can check it out. There is SOS linkage basically, right? There is SOS linkage present in S2O7 dinegative, right? Wherein, if you check over here, there is S single bond S, right? SS bond, there is no SS bond in the last one. Perfect. Moving on to one more. The elements of group 16 which show negative oxidation states are, see, all the elements of group 16, they show the negative oxidation states, right? Except, see, oxygen shows negative, absolutely correct. Tellurium shows a negative, correct. Selenium shows negative, correct. It's basically polonium which shows the positive oxidation state, right? It is basically the polonium which shows basically the positive oxidation state. So what was I supposed to check? The elements of group 16 which shows negative oxidation state. So it's going to be 1, it's going to be 3 and 4. 1, 3 and 4. 1, 3 and 4. Option C must be the correct answer of this particular question, right? Basically polonium is the one which shows the positive oxidation states, right, among the group 16 elements. Yeah? Perfect. All right, what do you think about this one? This is a very common question asked many a times, right? A group 15 element which is a metal and forms the hydride with the strongest reducing power. Among the hydrides, the element is. If you talk about the hydrides, for example, SBH3, for example, PH3, this is ASH3, this is BAH3. Which of the following is has got the maximum reducing power? Which of the following has got the maximum reducing power? It's absolutely going to be BiH3. Why is that? Because if you talk about BiH3 structure, there is a bond between Bi and H, right? Its bond dissociation energy is the least. If its bond dissociation energy is the least, it can give away hydrogen easily. It will undergo oxidation easily. If it undergoes oxidation easily, it can behave like the good reducing agent as compared to the rest, right? So it's basically going to be BiH3 among all the hydrides, which is basically going to be what? It's going to be the better reducing agent. That means it will be having more reducing power, right? Better reducing agent will have the more reducing power, yeah? Okay, the anomalous behavior of fluorine. Very common question. Every one of you would be knowing this, right? Anomalous behavior of fluorine. What is the reason? Small size, absolutely correct. Highest electronegativity, absolutely correct. Low FF bond dissociation and enthalpy and non-availability of d orbitals, absolutely correct, right? All of these. So it's basically going to be option D, which is the correct answer of this particular question, right? So D is the one which is going to be correct among all. I'm sure you're taking a note of every single thing which I'm telling you right now. Which one has got the highest boiling point, right? These are basically the noble gases which are given to me. Which of the following has got the highest boiling point? Boiling point, it depends on the van der Waals interactions in case of noble gases. So basically, more the size of the noble gas, more is going to be the van der Waals interactions, and more the van der Waals interactions means more is going to be the boiling point, right? Now, compare the size or the molecular mass, whatever is convenient for you. Absolutely, it's xenon, which has got the maximum molecular mass as well as it has got the maximum size, due to which its van der Waals interactions will be maximum and boiling point of it is absolutely going to be maximum among all the noble gases, right? I'm sure it's perfectly clear to everyone, right? Okay, the number of POP bonds in cyclic metaphosphoric acid. Number of POP bonds. How many POP bonds will be there, my dear people, in case of cyclic metaphosphoric acid? What do you think? What do you think? It's again a very common question. The structure is given in NCERT, right? How many POP bonds will be there? There will be 3 POP bonds, my dear people, right? There will be 3 POP bonds. This is 1 POP bond, this is second one, and this is third. There are basically 3 POP bonds in case of what? In case of metaphosphoric acid, right? Cyclic metaphosphoric acid I'm talking about. Yeah? So do remember this particular structure as well, right? Do remember this particular structure as well. Perfect? Let me move on to one more question. Which of the following reactions is an example of a redox reaction? So basically there are few reactions which are given to me. I need to identify which one is the example of the redox reaction. Let me start with the option number 1. If I calculate the oxidation state of xenon right here, oxidation state of xenon is going to be +4. This is O2F2, right? Oxyfluoride, +1. Xenon, +6. Oxygen, 0. Check it out. +4 to +6, decrease in the oxidation state. +1 to 0, increase, just a second guys. +4 to +6, not decrease, increase in the oxidation state, means oxidation. +1 to 0, decrease in the oxidation state means reduction. So the first reaction over here, it is the one wherein oxidation as well as reduction is taking place. So absolutely option A is going to be the example of the redox reaction. As simple as that, right? If you check the rest, they won't be the examples of the redox reactions. Okay? Alright, we are given the hydrides of group 16. Which one has got the highest boiling point? It's very evident, simple, and I'm sure you guys know it. What do you think about this one, my dear people? Among the hydrides of group 16, which one will have the maximum boiling point? Isn't it going to be the water, my dear people, because of the hydrogen bonding, right? Water, due to its hydrogen bonding, will have the maximum boiling point. So it's option A, which is actually going to be the correct answer of this particular question. Simple and basic again, right? Perfect. Right, people? Okay, the pair in which phosphorus atoms have the formal oxidation state of +3. Wherein do you see the oxidation states of phosphorus as +3? What do you think, my dear people? Is it pyrophosphorus and hypophosphoric acids? Similarly, you can check the rest. What do you think about this one? What do you think about this one, my dear people? Fast. What do you think about this one? Absolutely, Darshini, you are perfectly right. It's going to be option D. It's going to be option D. It's basically going to be orthophosphorus and pyrophosphorus acid, right? Your H4P2O7 and H3PO3, right? This is basically your H3PO3 and this H4P2O7. If you calculate the oxidation states of phosphorus, it's going to be absolutely what? It's going to be +3 only. right, in both the ones. You can check it out, right? Let's move on. Just give me a second, my dear guys. Just give me a second. Is this going to be the correct answer of this particular question? Is it supposed to be D? Plus 2, plus 3, plus 4, plus 5. This is plus 5. This one is going to be plus 2, plus 3, plus 4, plus 3, right? So, well, I'm not sure whether, well, people, if you check this one, this is H4P2O7, right? 1, 2, 3, 4, 5, 6, 7, right? So P double bond O, this is plus 2. Due to this, it's plus 1, right? And due to this, it's again going to be plus 1 only. So it's going to be plus 5, right? So let's keep this question as such. We'll do this at the end, right? Let's keep it as such. XCF2, XCF4, XCF6, the number of lone pairs on xenon are respectively. Say guys, you start with XCF2, right? You start with XCF2. Over here, xenon is the central atom. Its valence electrons are 8. How many sigma bonds it's forming? It's forming 2 sigma bonds, right? So out of 8 valence electrons, 2 of the valence electrons have been used to form 2 sigma bonds. So there'll be 6 electrons left as such on xenon in the form of lone pairs. So how many lone pairs are there? There are 3 lone pairs. So in XCF2, there are 3 lone pairs on xenon. In XCF4, you can check it out in the similar way, right? In the similar way, the xenon will have 2 lone pairs, and over here, this xenon will have 1 lone pair, right? So 3 to 1 is going to be the correct answer of this particular equation as well. Simple and basic, right? Yes, and I'm sure you got to know exactly how do we calculate the lone pairs, right? People, for example, if I talk about XCF4, right? XCF4, xenon is the central atom. It has got 8 valence electrons. How many sigma bonds it's forming? It's forming 4 sigma bonds. So out of 8 valence electrons, 4 valence electrons have been used to form 4 sigma bonds. So there are 4 electrons left as such on xenon in the form of 2 lone pairs. This is how you calculate the lone pairs. I'm sure you all must be knowing about this, right? So option D is the one which is correct among all, right? Okay, C60 an allotrope of carbon contains, right? A very common question directly from your NCERT. What do you think about this one? What do you think about this one, my dear people? What do you think? Absolutely, it's a memory-based question, right? There are 20 hexagons and 12 pentagons in case of C60, right? Which is basically the aromatic allotrope of carbon. 20 hexagons and 12 pentagons in case of C60. Very common question this is. Okay, the type of hybridization and number of lone pair of electrons in XeOF4 respectively. Well, if you talk about XeOF4, yeah? If you talk about XeOF4, my dear people, this is Xe, for example, this is O, this is F4, right? This xenon is the central atom. It has got some 8 valence electrons. How many sigma bonds it's forming? It's forming 4 plus 1, 5 sigma bonds. The number of terminal atoms attached, gives you the number of sigma bonds. So there are 5 sigma bonds, right? Now, if you want to make its rough structure, X, and there is one oxygen which is bivalent, you know, this is fluorine, for example, one more fluorine, one more fluorine, one more fluorine. This is its rough structure. So out of 8 valence electrons, how many it has used? 1, 2, 3, 4, 5, and 6. Out of 8, it has used some 6. So there'll be 2 electrons left as such on xenon in the form of a lone pair. So there is 1 lone pair. So 5 sigma, 1 lone pair. So what about the steric number? 5 plus 1, that is 6. If the steric number is 6, the hybridization is going to be sp3d2, right? This is the hybridization sp3d2. Perfect. So you got to know the hybridization is sp3d2 and there is 1 lone pair on xenon, right? So option A is the one which is correct among all. Perfect. Simple and basic again. Let me quickly move on to one more question, my dear people. The correct order of catenation. Every one of you should know this, right? If you talk about the group 14 elements, right? If you talk about the carbon family, carbon has got the maximum tendency to show the catenation, right? Because CC bonds are really very strong as compared to the rest. Perfect. And as we move from top to bottom, size increases, the tendency to show catenation that also decreases, right? So what is going to be the correct answer of this? First carbon, then should be silicon, then germanium, then tin. So it's option C, which is the correct answer of this particular question as well. Yeah? Right, people? Option C is the one. And this is the order, if you want to have a look, actual order. Carbon's catenation power is far, far, far greater than that of silicon, which is greater than that of germanium, and germanium almost is equal to 10, right? Almost. This is the actual order. Do remember this one. The set in which the compounds have different nature. The set in which the compounds have different nature. What do you think about this one? Where do you see the set wherein the compounds have the different nature, my dear people? This is BOH whole thrice, right? This is basically H3BO3. It is boric acid, right? It is acidic in nature. It looks like a base, but it's not a base, right? It's the acid, BOH whole thrice. It's the boric acid. ALOH whole thrice. It is amphoteric in nature, my dear people. It is amphoteric in nature. Perfect. So first one is the one which is correct among all, right? Yes. Otherwise, this is acidic, right? Same nature. Perfect. This is amphoteric, same nature. This is basic, same nature. So option A is the one which is going to be the correct answer of this particular question. I'm sure you're remembering all these things with me. The number of 2-center 2-electron and 3-center 2-electron bonds in case of B2H6, right? Well, if you talk about B2H6, it has got a very common structure. I'm sure you all must be familiar with that. If you talk about the B2H6, right? Let me make the B2H6 over here. It has got 2 banana bonds, right? So basically, this bond, this bond, this bond, and this bond. These 4 bonds are what we call as 2-centered 2-electron bonds, right? Let me leave this particular bond and this particular bond, which you call as the banana bonds as well, right? Which lie above and below the plane. So the 2 bonds are going to be 3-centered 2-electron bonds, right? 3-centered 2-electron bonds. So check the correct one. The number of 2-centered. There are 4 2-centered and 3-centered 2-electron. 2, 4 and 2 is going to be the correct answer of this particular question. Simple and basic, right? Yes, my dear people? Absolutely. Moving on to one more question. Look at this one. All right, what do you think about this one? This is again a common question in which majority of the students, they do mistake in this one, right? The order of acidic strength of boron trihalides. Order of acidic strength of boron trihalides. What do you think? Right? That's great, Ninja JEE. What do you think, guys? This is a simpler one, right? Very simpler one. See, I told you majority of the students are going to give the wrong answer. Majority of the students are giving this as the answer, but this is not. This is not. It's option A, right? Why is that? See, normally what an ordinary guy thinks, he thinks like this. This is B, this is F, this is F, this is F. So more electronegative element, maximum electron deficient center, electron deficient, so it's going to accept a pair of electrons, it's going to be maximum Lewis acid, right? But people, you forget, boron, its octet is not complete, right? Its octet is not complete, right? So there can be back bonding possible from fluorine towards boron, right? Due to back bonding, the electron deficiency of this boron center gets minimized. So if I ask you which of the center is least electron deficient, it is going to be this boron which is least electron deficient. Which one of the following will be maximum electron deficient? This boron is going to be maximum electron deficient, right? So wherever boron is the maximum electron deficient, there only it's going to be more acidic, right? Because over here, there is maximum tendency to form back bonding, right? Yes, because of the PP back bonding, right? Over here, it's not going to be PP back, yes, this is 2P2P back bonding, over here 2P3P back bonding, and so on, right? So it's option A, which is the correct answer of this particular question. Do remember this from now onwards, right? Yeah? Okay, moving on to one more. Thermal stability, what do you think about this one? Thermal stability, my dear people. Hydrides of group 16, right? It's again going to show the same trend, right? H2O is going to be maximum stable, followed by H2S, followed by H2SC, followed by H2T, followed by H2PO, right? So it's absolutely going to be option C, which is the correct answer of this particular question, right? Perfect. It's a very common question. And the reason is the same, bond dissociation energy. Okay, which of the following on thermal decomposition gives oxygen gas? What do you think about this one? Which of the following on thermal decomposition gives oxygen gas? See, Ag2O, when it undergoes thermal decomposition, it gives, right? It gives O2 gas. Pb3O4 also gives O2 gas. PbO2 also gives O2 gas, right? So it's option D. All of the 3, basically on thermal decomposition, they produce O2 gas. And you can remember these reactions as well, right? You can remember these reactions because these reactions have been directly taken from the NCERT. Right, people? One more. Which of the following does not give oxygen on heating? Right? Which of the following does not give oxygen on heating? It's going to be NH4 twice Cr2O7, right? This particular species on heating, it does not give O2 gas, it produces N2 gas, right? This one, it does not give O2 gas, it produces N2 gas on heating. Whereas all the other things on heating, they give O2 gas, right? So if you look at this one, it produces N2 gas over here, right? So do remember these reactions as well. Perfect. All right. NaOH plus SO2 gives A plus water. When NaOH reacts with SO2, it gives Na2SO3. It gives Na2SO3, right? B plus water plus SO2, it gives NaHSO3. So this B is supposed to be Na2SO3 only, right? Na2SO3 only plus water plus SO2, it gives sodium NaHSO3, right? Yes? Perfect, guys. So it's option A only which is the correct answer of this particular question. Do remember, both the reactions are given in NCERT only, right? And these are the reactions, which I've already mentioned. All right, aluminum chloride in an acidified aqueous solution forms a complex A. In which hybridization instead of aluminum is B, right? First of all, what is the complex? Does it form the tetrahedral complex or octahedral complex? It forms the octahedral complex, I'm sure, right? This again the statement which is given in NCERT only, right? So it forms the octahedral complex. It forms AlH2O6 tripositive. This is the complex which gets formed. Now I need to calculate the hybridization of this aluminum over here. See, aluminum right here, it has got the oxygen state of +3 because water is a neutral again. So if you talk about the Al plus 3 configuration, outermost configuration, it is going to be 3s0, 3p0, right? Similarly, 3d, 0. Perfect. So what is the coordination number in this particular case? Since there are 6 coordinate bonds basically, so this Al tripositive, it has to arrange some 6 vacant orbitals for hybridization. So what are going to be those 6 vacant orbitals? These are going to be the 6 vacant orbitals, S, 3p and 2ds, right? So there is sp, 3d2 hybridization involved in it, and option D is the one which is absolutely going to be the correct among all, right? Simple and basic again. Right, people? Okay, the formula of mineral borax. What is the formula of the mineral borax? Let me know quickly the answer of this one. What do you think about this one, my dear people? No, I'm talking about the mineral borax, my dear people. Mineral borax I'm talking about. Absolutely, Darshini, you are again right. Yes, Lalita, absolutely. Yes, Farha, it's going to be option D, which is the correct answer of this particular question. It's Na2B4O7 10 times water, right? Okay, so this is basically going to be the formula of the mineral borax, right? The bonds present in, this is borazine, right? Make it as borazine, which is what you call as inorganic benzene, right? How many bonds are there in borazine, which you call as inorganic benzene, my dear people? How many sigma and how many pi will be there? First of all, this is something which you should, why not D2sp3? Because it was a weak field ligand attached, right? And that too, it was Al tripositive. Okay. So people, what is going to be the correct answer of this particular question? What do you think? Well, if you do not remember its structure, then you cannot answer this particular question. It's going to be 12 sigma and 3 pi. Have a look on this structure and do remember this particular structure as well. Do remember this structure, my dear people. This is the structure of your inorganic benzene, or you call this as borazine, right? So there are some 12 sigma bonds and 3 pi bonds involved in this one, right? Which of the following is formed on dehydration of formic acid? When you dehydrate formic acid, HCOH, right? What all things you get? You get water plus carbon monoxide, right? Simple. When you make it to react with the acid concentrated H2SO4, it's a very simple reaction. So carbon monoxide and water is produced. So over here only carbon monoxide is there. So option A is the one which is correct among all. So HCOH, right? It gives H2 plus carbon monoxide. Simple. Producer gas. Which of the following do we call as the producer gas? Which of the following we call as the producer gas? Absolutely option A, my dear people. Carbon monoxide plus N2 is something which we call as producer gas, and this is how it gets formed. Again, the statement and the reaction directly taken from the NCERT, right? Which type of zeolite is used to convert alcohols directly into gasoline? Again, the statement from the NCERT, my dear people. What do you think about this one? Is it going to be ZSM3 or ZSM5? ZSM3 or ZSM5? Absolutely, it's ZSM5, right? You all are perfectly right in this one as well. Perfect, guys. Okay, pure nitrogen is prepared in the laboratory by heating a mixture of. How do we prepare what? Pure nitrogen. NH4OH plus NaCl, no. NH4NO3 plus NaCl, no. NH4Cl plus NaOH, no. Option D is the one which is the correct among all, my dear people, right? From this particular reaction, option D, right? From when NH4Cl is made to react with NaNO2, you get the pure nitrogen from the lab, right? So it's option D, which is the correct answer of this particular question as well, okay? Again, a very common question, right? Which of the following statements regarding allotropic forms of phosphorus is incorrect? White phosphorus is more reactive than red, absolutely right, and black due to high angular strain. Yes, perfectly correct. Option A is perfectly correct. See, option B says red phosphorus on heating catches fire and gives dense red fumes of P4O10. Is this right, people? It should not be red phosphorus here. It should be white phosphorus, right? It should be white phosphorus, right? White phosphorus on heating catches fire, right? White phosphorus catches fire, my dear. It's not the red phosphorus. So option B is the incorrect one among all. Option B is the incorrect one among all, right? Okay, it's option D. Again, a very common question. In solid state, PCl5 is. In solid state, PCl5 is. First of all, it is an ionic solid which exists in the form of PCl4 positive and PCl6 negative, right? So this is how PCl5 exists in the solid form as the ionic solid, right? Okay, so this one is going to be tetrahedral and this one is going to be the octahedral, right? This part is tetrahedral and this part is octahedral. So look at all these options. PCl4 positive, where do you see PCl4 positive? PCl4 positive, PCl6 negative. So option D is the one which is correct, right? Okay, which of the following orders is not in accordance with the property stated against it? Property stated against it. HiHbr, HCl, HF, acid property in water, this is correct. F2Cl2, Br2, I2, electronegativity, this is correct. F2Cl2, Br2, I2, bond distribution energy, this one is incorrect, right? So actual order is Cl2, then comes Br2, then comes F2, right? And then comes I2. This is the actual order. So this one is incorrect. So option C is the one which is correct, right? Option C is going to be the correct answer of your particular question, right, people? So with this, I'm sure a lot of things in your P block elements would have got covered, right? So these 50 questions, I'm sure you're going to get the PDF of this particular session in the Telegram group, my dear people. And if you're not liked the video, please do like the video, share the video with your friends, and do subscribe to the channel as well, right? Well, tomorrow at the same time, 9:30, we are going to have one more mock test for the ones who are going to write the JEE in 2022. Do attend that mock test as well. That's going to be our 26th mock test, my dear people. So till now, we are done with 25 mock tests, and tomorrow it's going to be the 26th mock test, right? Hey, ma, I don't remember exactly whether I have finished states of matter and the most expert questions. Well, I'll check it out. If not, then I'll come with states of matter soon. Okay? Perfect. All right, people. I wish you all the luck, right? And well, there is the open test going to happen on 7th of April, right? Do attend this one as well if you want. If you're aiming for the JEE Advanced. If you want to get enrolled into our ACLOWeb program, right? Do get enrolled as soon as possible in this one by joining in the test on 7th of April, right? So, and if you have not liked the video yet, please do like the video, share the video with friends, and do subscribe to the channel, and do let me know in the comment section if you like the video or not. So with this, I'm going to take a leave here. I'll see you tomorrow at the same time. Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.